Okay, this is 4.27, chapter 4, number 27, where it says separate samples of a solution of an unknown salt are treated with dilute solutions of Hibber, H2SO4, and NaO. A precipitate forms in all three cases. Which of the following cations could be present in the unknown solution? So organize this and put K plus here, and we'll run some reactions. Put Pb plus 2, and we'll run some reactions. And then put Ba plus 2 right here, and we'll run some reactions, and we'll see which ones would form precipitates and which ones wouldn't. Got to know your solubility rule is really good here, so have those out in front of you as well. So first of all, it says that you'd have to be able to react it with Hibber, and you'd have to be able to react it with H2SO4, and you'd have to be able to react it with NaO over here, and you should get a precipitate. That means a solid, something that does not dissolve when you react it. Since this is a cation right here, it'll come and replace the cation for each one of these things. So you'd end up with KBr here, K2SO4 right here, since sulfate's -2 and potassium's +1, and KOH right here. Now you have to look on the solubility rules and decide, are these precipitates? Are they solids that do not dissolve? Then it would fit the characteristic about something that could be in the solution. So KBr, well, first of all, anything in group 1 that contains potassium is soluble. Oh, that kind of ends that. That means that if it contains potassium, it's going to dissolve. So every single one of these is aqueous. So automatically, that rules this guy out. Potassium could not be present in the solution. Okay? Second of all, let's try lead now and react that with HBr, and react that with H2SO4, and react that with NaOH. And once again, since this is a cation, it would replace the cation in each of these, and we'd end up with PbBr2, some PbSO4, and some PbOH2. Remember, lead's +2. It told us it's +2. And then hydroxide's -1, sulfate's -2, and bromine's -1. Get your charges right on there. All right, let's see if this is soluble. Well, it says all bromides are soluble except for silver, mercury, and lead. Oh, so this would form a solid. Okay, possibly. Lead sulfate, let's check that out. All sulfates are soluble except for barium lead. Oh, lead sulfate, so that would form a precipitate. How about lead hydroxide? Well, down here it says all hydroxides are insoluble except for the 1A and ammonium, barium, strontium, and calcium. Well, is it in the 1As? Well, the 1As are lithium, sodium, potassium, rubidium, cesium. No, lead's over here. So that means lead would form a precipitate there. So that means, yes, lead would be in that solution. Or it very well could be in that solution because it formed precipitates with every single one of those. Let's look at barium. Decide whether that could be in there as well. And once again, react that with every single one of these. Find out what it would form, and since barium's a cation, it'll of course replace each one of these cations. So we ended up with BaBr2, with BaSO4, and then some BaOH2. BaBr2 right here, because bromine's -1. So look at this right here. Bromides, all bromides are soluble except for silver, mercury, and lead. Well, that means barium bromide is going to be soluble. So that would be aqueous. So that one will dissolve. Okay, so that means barium can't be present in there because it said precipitates were formed in all three cases. And I just found one case where it's not going to form a precipitate. Now, this one, barium sulfate, if we just want to finish it up, this one would also form a precipitate because it says barium sulfate is going to form a solid. Barium hydroxide, though, hydroxides are insoluble except for, oh, barium's listed on there, so that's going to be aqueous. So 2 out of the 3 cases there could not be barium in that solution. So the only thing that would be in that solution would be lead.